Victor, you're still muted.
So, thank you, Christian, for the introduction. Ciao a tutti, buongiorno, bonjour, grüezi. We discussed and we do it in English. It's my first speech in English on LibaService24, because normally we are in Italian, in French, or in Schweizerdeutsch. And thank you for the opportunity to be here. And if you have questions, you can at the end or immediately ask. We make electromobility even safer. That means electromobility is very, very safe. Each day we have 2 cars that burns gasoline cars, but if 1 car in Europe will burn sometime, we have a huge message, and that's not correct. But who is we? This is Adrian Müller, my partner and founder. He's also head of recovery company in Zell, and me, and of course our partners. We have over 22 partners in whole Switzerland. We are specialized in recovery, transport, quarantine, recycling of accidental cars or batteries, or others that's with lithium-ion batteries in the business. It was a service for 24.
Victor, very quick, thanks for the introduction, but as far as I know, you prepared a presentation, so I think you need to share it again, so we don't see the presentation.
It doesn't move. My presentation is moving, okay.
Yes, no, it's not shared, you need to share it again.
I should share it again as last time, so excuse me.
No problem.
Just a second. Now do you see it?
Yes, not yet in the presentation mode, but we see
coming. Great. Okay, you see it, Christian?
Yes, but still in the not presentation mode. I think you share the window and not the screen.
Yeah, okay. Come. Now do you see it?
No. I think before we saw quickly your whole screen, and then I think you could share.
You don't see it now.
Presentation. Now, this is slide number 3.
You see the screen now?
Yes.
So we make like this. So you make like this. Okay. I'm sorry. Good. We have 24 partners in the whole Switzerland, and we are able to, in 40 minutes to be at the accident site where something happened with an electric car, for example, or with a battery. Our partners have the same standards, the same equipment, and the same processes. But what we see, what our challenges are, that's what we see not every day, but from time to time. In Switzerland, I go a little bit further. Here we see Tesla. He missed the parking space, as it seems. And also here we see the battery is broken here. It's not very good. It's dangerous. And you need to get this car away. And here we see a storage for a car. You see everything is good made, and also with the signs, but such a car you should not store here with tires. The car could be like a match, and here we have a lot of things that could burn. That's not good, it's dangerous. And on the side, it's here Mercedes. You could see this was in an accident in Friday evening, and they put it then to the garage in the wrong manner. And the garage, they told, okay, we take it in the garage over the weekend, and on Monday we look for it. And that was not good, because if you have a car from an accident, you should go first to quarantine and then to look for the specialist, what's with the battery. And also the Mercedes garage then saw that the pyrophase is triggered, and the airbags, and the battery should go out of the car. And they made an offer to the insurance, and the insurance, they said, oh, to repair is too expensive, and they put it on a selling platform, and in 10 hours it was sold somewhere in the east. And even in the platform, they have written it's an Outfall code, a waste code, that they sell waste on the platform for the insurance. That's not good, because this battery, they're maybe not safe. Somebody should look if the batteries in future are again to put it in a car or not. Or here, loading, very interesting thing. They are very specialist. You see, this is a Tesla. And here you see from the forklift, the forks, they are here on the top. That means they go under and press the battery from a damaged car. Very professional work. Or our friends in Germany, sometimes also in Switzerland, they like to put cars in containers with water. That may be good, but afterwards, when they come out of the water, somebody has to take out the battery. It's very dangerous. Or only batteries we found sometimes with recyclers or place or fireplaces. Some modules, here some Tesla modules in a plastic box, they are wet and they have tensions, or here from a burnt car, or also here from a forklifter or the pouch cells. Very, very interesting things. Now, what to do? That's our not daily business, but day per day we have more such issues. Electromobility is booming. If you want, if it's a good thing or not, at least we need in Switzerland another 2 power plants, nuclear power plants, but I hope we will have enough energy for it. When we go for the cars, when we see where we have even batteries, we see even more and more the 12-volt starter batteries in the cars that are lithium-ion batteries, and there we have really to pay attention not to mix with the lead starter batteries. We have each 3 or 4 months container burning because of this issue, the mixing of lead and lithium-ion batteries. But we have mild hybrid batteries. We have from the hybrids batteries. We have there less than 50 volts. They're not so a big thing. They're not the power, but it starts at the plug-in hybrids. We have over 350 volt, and then from the all electric, we have 400 to 800 volt. But also the fuel cell cars, there we find the batteries in. These batteries with this high tension, they are very, very effective. But in case of accident, we have also some issues. Challenge in dealing with the lithium-ion batteries. This is not only for the recovery in quarantine, but it is a whole cycle of what we have to fulfill. And I will explain a little bit what we do, because I say a battery that's in use, it's a good battery. A battery that's recycled is a good battery, and battery that's fully burnt is a good battery. All the rest, they are in Swiss German betäterlich. So that means you never know if they will burn or not burn, or what happened with them. So we have a process for recovery from the Federal Office of Road and ASS, that's the Association for Recovery Cars. Then we look for ADR, that the dangerous goods regulations, lithium-ion batteries are dangerous goods. Then we have ordinance and transport of waste, FEFA, we have to look. We have to look on work safety and fire safety. We have to go for warehouse processing, fire protection regulation. And we have also chemical risk reduction ordinance, the GmbH. And then we have, if possible, we can take from the battery prototypes second life, or we go for material recovery. I'll go first for the recovery, for the process that we have here is very important. Cooperation with fire brigade, police, and the car recovery service. In Switzerland, we have a clear process from the Federal Road Office. That means in an accident, we have 8 levels. A level is a normal breakdown of a vehicle. That's you recover it as normal. Then we have a damage, an accident without airbag deployment. We have some smaller issues, or we have it from an accident from the vehicle with airbag deployment from a hybrid. The hybrid have normally small batteries, and there we have to get rid of the currency from the current. And there you don't need any protection system. But here in the vehicles with lithium-ion batteries, we need a fire protection system when we have an accident where the airbag are deployed, or we have major damage on the high volt system, or the car is flooded, or the vehicle is partially burnt out, or is fully burnt out. Then we must take a fire protection system from the recovery, transport, and for the quarantine. And the internet site, you will see the whole process from the accident, what is then to do. We have all the checklists. We can read it. You will find it then on the internet site. I will give until quarantine, what's coming out from quarantine, if it burns in the quarantine, what is to do, or the checklist if it don't burn. And this recovery system, if you have no fire in this recovery system, the car is the same as you put it in. It's not flooded, it's dry, and if it's burned, then it's of course broken. And then we have the issues. We can take the battery out of the car and to separate it, or we can bring the whole car then to the OEM, to the importer. Here you see, this is the website of ASTRA, the Federal Office of Road. There you can find all these processes. It's not in English. It will be in Italian, in French, and German. You see, for example, such a recovery transport quarantine. It's a LibaRescue. It's a bag. It's a textile. It's 130 kilo in weight. It's rolled. You can roll it out on the ground, and you put the car in. And the issue is the car, electric car. Normally, all the wheels they are fixed. You cannot move the car. Therefore, all our partners, they have a crane and can put the car on the LibaRescue and take it then here with the truck, for example. This takes about 15 minutes to take the car into LibaRescue and put it on the truck. Also for garage, we have there's a process. When you have a garage manipulation, the car, and the car is strange, electric car. Normally the internal measures fits, and you can bring the car stable about 98%, I hope, and then the garage has no problem. But if the car is in a critical situation, it's better then to alert the intervention. That means the fire brigades and also us. If they are on site, they will decide the intervention. If it's no fire, then maybe they will cool or they will do nothing. If there will be a fire, they extinguish the fire, and Then is to finish, the fire is extinguished. Then you have to take the car also again at phase 8 to a Liba rescue and take it in quarantine. And after quarantine, you take it out and look what is to do. Or in this case here, if the car is recovered, then you have to decide if we take the battery out from the vehicle, then we take the battery itself for recovery for quarantine, or we take then the whole car in quarantine and take it with us on our side for quarantine and look afterwards with the garage or the OM what is to do, if it's a repair or disposal of the car and the battery. For this issue, for the garage, we recommend the fire retardant blanket because it's the only thing that the garage can do immediately. That's it's a special textile, a silica textile that is over about 45 kilo in weight, because it must be weight, because if a car is burning, we produce a lot of smoke, and the smoke is a pressure, so light blanket, they'll be fly away. And this is also textile that takes water. That means with the water evaporation, we have also cooling effect. And this textile goes to 1300 degrees C. It's a silicate fabric, and also it's a protect for the colors, for the paintings of the car, that nothing will break. Because in most of the situation, the car will not burn and will cool down, but if something happens, we give even the fire brigade about 20 minutes more time to a full fire. That's the idea of this fire retardant blanket for the garage. Now I come for an accident, elementary in practice. It was a Tesla tree. It was last year in heavy rains and extreme hail. See, it was in August, it was like snow, but it was everything full ice. Then they had vehicle level 6, flood damage. Then we get to recovery with fire brigade, and we took then the car. Here is the Liba rescue on the side of the truck, and we put the car on the truck, and then we closed the Liba rescue and took the car in quarantine. Then we have discussions with the insurance, what is to do with this car. And we recommend to take out the battery, look into the battery. We are afraid that the battery inside is wet, and it's a EP67. Normally should not be wet, but we opened it. We took here the battery down, and you see here the flooding was until the seat here. And this is the connection, electric connection from the battery to the motor. IP67, you see it's not even water, it's also sludge is in these connections here. It's not so good. Because of that, we decided then to open then also the battery. But first we took the battery out of the car. So here we have the dangerous goods, the battery, and here we have the car for reselling for the insurance without any danger. We took this battery according to the large package 904, that means a defectus battery. That means we have here this Liba box, and with the inner package here, inner protection and the outer protection, and so it's closed, and so we have the dangerous goods separated from the car. And of course we have here an orange plate also in front, because it's a dangerous good transport. We have here this trailer, because if we would have a fire, we have only on the trailer this fire. Don't open the box. It's tested for burning, but we have, of course, we have some smoke that's not very good, but it's better than open fire. Then we open the batteries. Here, it's the inlet of the currency, and you see here we have 340 volt after this flooding, and it was strange because from the plus pole of to the battery outside, we had 120 volts, and also from the minus pole to the battery outside, we measured also 120 volts. That means the relay inside were also flooded, and here you see the battery management system. It's also flooded, it was wet, and after 10 days we have a lot of corrosions inside the electrical high voltage part of the battery. Then you open the rest. Here you see 3 models of this Tesla 3. The models, they are mostly were dry, but only in the bottom of the battery we have found some water. But you've seen also in other cars the same situation. It looks that when the battery is hot and is on the water, the gases in the battery, they will be cold, and so we have a contraction of the gases, and in this case we have a slight under pressure in the battery, and this under pressure sucks water obviously through the cable inlet to the battery. You've seen the overpressure valve, normally they're very good. There also we can go to garage or partners to get batteries. Then normally the battery, when we go, it's in uncertain condition or not safe condition. Then we have to check the battery, or we do it with infrared and visual, and then we decide if we can take it or we put it in quarantine. And then we take it with us, also with the orange plate, and then we make the disassembly of the battery until we have modules, and these modules then will go to our partner Batrec direct for recycling. That's a good battery, as I said, and a recycled battery, then it's really safe. We can do that also for forklifter. Then the battery is about 1.5 tons. You see here where the issue last year is a forklift batteries, and also we go with the other box to get this battery safe, and we put it to the OEM for quarantine and then dismantling to look what happens. But this time was not a big issue, but the battery became very hot. It was a lithium-ion battery. Now when you look for recovery and lithium-ion batteries, dangerous good. What is to do then? It's always when we transport these batteries on the street, we must transport according to these issues, and we have batteries is a UN code 3480, and that makes it already a little complicated. In our case, for example, there was a sender, not we, but we were the packer, we were the shipper, the driver, and the unloader. We make the service, and that means we have to fulfill a lot of obligations and shipment documents, ADR, shipment documents, FIFA, because when it's defectors, then it's a waste. Then we need also transport according the waste ordinance. And from the sender shipper is a huge checklist, because it has to check that the packer, shipper, transporter, we really have to do. I will explain shortly and simplified what is to do. For example, the sender, he must make the clarification whenever the goods are dangerous and they're authorized for carriage in accordance with the ADR. There are some things that are not allowed to go to the street. They must check also the documents, and if the marking of the labeling of the goods and the packaging, the packer really they have to look at the correct goods and correct packaging. They are marked with labels in accordance with the package regulation. And of course, the shipper has then to look that the vehicle is properly equipped for transport. The driver is allowed to carry the transport. You need the special certificate. If you have over 1,000 points, that means over 333 kilo of the battery. If it's less, the driver needs instructions, and you have to check documents, the freight and freight if it's matched. Are the goods correctly labeled? Is the package undamaged? Then for the mixed loading, you have to look. You cannot load everything together according to ADR. Then loading, securing. Then the warning panels. If you have more than 330 kilos with the batteries, And then also the driver has to look for his vehicle, if it's properly equipped for transport, documents, image. You see, there are a lot of things you have really to look. There's all the duties. And if a garage in Switzerland will be a sender of a battery that's over 333 kilo, they even need a dangerous goods safety advisor, because then they are a sender from dangerous goods, and according to this law, you have to do much more than a lot of people know what is to do. Also for us, it was very difficult, all these things. We were different formation for that, but nobody can explain us really what we have to do, because here you see all these special regulations according ADR, das als Sondervorschriften. And therefore we made with ASTAC together formation for education for ADR and lithium-ion batteries. But in a nutshell, to try to make it a little bit easier, normally we have this kind of batteries. We have new and used batteries, small ones, less than 100 watt-hours energy, and we have new used batteries with over 100 watt-hours, and we have small series prototypes, and the end of life for recycling. We have defect batteries and critical defective batteries. And the issue is, before you know what you have to do with ADR, you must know the battery and the status of the battery. If you don't know that, you cannot transport it according to ADR. We had a lot of discussion with the police, because we asked them always what is to do, and they didn't know that. And so they come to us, to our education with ADR, lithium-ion batteries, and also they have to control it. They know is what to do. But to really know the status of the battery is difficult, because we normally cannot communicate with the battery management system like the specialist can do. And of course, in this case, end of life, defect, critical defect, this is a waste. There you need also waste transport documents, and all the rest here need shipping documents according to ADR. Now, the next issue we have to look at the ordinance in the transport of waste, FEFA. That means this is if it's defectus, if it's end of life or critical defect, this is a waste according FEFA code 160697. That means you can only give the batteries to an authorized company that is in charge to transport this waste code and take also this waste on their site to treat it. That means if there's a battery end of life, I'm not allowed to give it anyway on a selling platform to the guy that pay most money for it, for example. There we have to look for this ordinance. So what's also very important then is the work and fire safety. But as I said, lithium-ion batteries, they are safe. But when, in which condition lithium batteries, they are not safe in our opinion? First, when we have an undefined condition of a battery. That means when I have an old battery, sometimes a 20 years old battery from an electric bicycle. What happened with this is it was used, it's broken. When we see a mechanically damaged or deformed battery or penetrated, when it's electrically damaged, normally you don't see it first. Or we have incorrect charging. We have use of incorrect or manipulated chargers. I think everybody from us is doing that with smartphones and so on. Maybe it's not the best idea. And we have deeply discharged batteries, it's not visible. Normally you cannot reload them because the battery dimension closes, but we have seen different fires because of that. That means people, they load a deep discharge battery, and there are also some specialists that try to reactivate a deep discharge battery with very low tensions over hours, maybe also not the best idea. And damaged battery must not be charged. It's very important. For the cars, when the airbag is gone, with deformation, penetration, excessive temperature of the batteries, there's all problems that give some issues or danger. The dangers are fire hazard, electrical hazard. That means over 60 volt DC, it's become dangerous. 120 volt DC, it's little. Then in the smoke, if you have a fire, you have toxic smoke, and in smoke we have also fluorine acid. And of course, if you have deflagration, if you have heavy reaction. I will show here a reaction of a battery. Is our test module. Everything we do, we test. We make some pyromanics action. You see here this module, 2.5 kilowatt hours. We make ignition. You have seen first the heavy fire. This is thermal runaway. Now we see all the rest of plastics, they are burned. But now we look what happens. It's difficult in this way. Sorry, have to improve. First, we have battery that we have overpressure, like this. This is a pouch cell. Then the second, we have an overpressure valve. The valve that goes, the gases go out. Normally, then the reaction is gone. But when we have more of them, then the pouch cell or also cylinder cell or prismatic cell, they open, and then the smoke we have hydrogen in, we have burnable gases in, goes out, and then the issue is that the pressed electrolytics that is burnable with the smoke goes out, and we have here the flashes, and so we have then the fire. And this fire you cannot distinguish. People, they say they have issues to do it. They have never seen that. They wait until the thermal runaway is gone. Afterwards, they will distinguish what's in the rest is. And this is very short, it's very heavy, and it's like a big match. But then you have to look that we have nothing else there in near that it's that can burn. And when you look for the failure, what we see we have an external short circuit. We have deformation, a penetration. We have internal defects. We have too high temperature. Then we have the issue that we have all these cells together, and if the middle they will break, the other ones they will also become hot, and then we have a chain reaction, so-called thermal runaway. And when you go deeper in the cell, we have here the anode with the copper anode to get the electrons. We have here the graphite anode. We have here the layer, solid electrode interface. We have electrolyte, separator, electrolyte, and here the cathode. And now when this becomes hot, first we have the solid electrolyte interface on the graphite goes in reaction at 70 degrees. Then we have a reaction with the electrolyte, and then it becomes hotter and hotter, and then the separator will fail, and you have a shortage, and then short circuit, and then also the cathode becomes warm, and this cathode will release oxygen. That means, in a nutshell, if the cell is over 70 degrees, the problems with exothermic reaction will start. And in the battery, the cell will produce the oxygen itself. That means it closes the fire triangle with oxygen, with burnables, and a flare for ignition. And that's the issue why the batteries are very, very difficult to distinguish. You have to see here, for example, a battery. This is a closed housing, and inside we have the failure in the cells. And inside there, they produce the oxygen. We have sparks and we have something to burn. That means this battery will burn through. And if we want to extinguish, we cannot go inside this battery. And therefore, if it burns like this, let it burn, and afterwards you have a burnt battery, it's still safe. And if people try to extinguish for one battery, you need about 10 cubic meter water, and normal fire truck has about 2 cubic meter water with it. As it's difficult to extinguish a battery fire, and the battery produces itself the oxygen for the fire. But the good thing is it's not too much oxygen to make a big fire, but at the end we will see it. And here we have another fire incident. It was last month in the canton of Lucerne. There was a car dealer. They had about 30 cars and also electric cars, but he bought from an insurance electric rollers, scooters, and the scooter was charged, and the fire came from the scooters, about 5 scooters, and go then to all the other cars. There were 2 total electric cars and 5 hybrid cars. We had then to recover. It was difficult. Even the Tesla was burning, and this was a very difficult thing. So pay attention with cars with battery. You don't know the history behind. This is an issue that was not professional, and never charge battery you don't know, or you are not sure that they are really safe. Then we have the warehouse processing, fire protection regulations. If we have in the storehouse batteries, we have of course also look for them. So we have different obligations. First of all, see the operation instruction from the manufacturer. There you have a lot of information. For example, my e-bike, in this instruction, they say, never put the e-bike in direct sunshine, and never load it in sunshine. And since then, I also only go with my e-bike when it's raining. So it's, yes, it's standing in there. Then we have also building protection insurance. That's important. This is a Brandschutzmerkblatt. It's not in English, also French and Italian. You will find it on the internet. There you have some information. And here, of course, which batteries to store. Of course, new lithium batteries, used lithium batteries you have in repair. But defective lithium batteries, end of life or critical, do not store. Move them for recycling and get rid of them. It's no use to have fire potential in your storage magazine. Smoke gas management is very important. I have a lot of discussion in the storage, and they say, no, we have fire protection is very good. When I tell them the fire is maybe not so big, but we have huge issue with the smoke. I will show here 99 Swiss francs issue that we put batteries in. You will see here, it's 2.5 kilowatt batteries, and here we make ignition, and you see here the smoke that's coming out. So this 99 Swiss francs part here, it was enough that no fire outside. But with the smoke gas management, you see that we have here really an issue. This is only 2.5 kilowatt hour. And you have seen here, everything is burnt, the whole battery is burnt. Nothing big happens, but everything, of course, if you have it in a magazine, in a storage magazine, everything is full of this toxic smoke. This smoke is also hydrofluorine. That means if you store it, then you have really to look, if something happened, where goes the smoke out? And there from the classifications level, this is information from the building insurances, they look, of course, for energy density per volume. Here you have the risk, low, medium, high, the storage, kilowatt hours per cubic meter, for example, or this is for batteries. Storage system, this is our batteries for PV cells, for example, or electric cars. Normally, we were always in the high level, that means has a level 3, that means you need there special fire protection sections. But the risk of the fire is very small if you have undamaged batteries, and if you do the things according to manufacturer specification. So the batteries, they are really safe. From a statistic point of view, fires, they happens mostly if you have an accident or if you load the battery. But if you have no action with the battery in the storage, it's really very safe. If you have batteries, for example, they are dangerous. There are possibilities with such container boxes that people from garage, for example, put it in such a box and leave it there in quarantine, and afterwards they take it out and make demanufacturing and look then really what is in, what happens, and what is to do. In a nutshell and simplified for storage, first, separation batteries for other hazardous goods. I was in a garage, they had a really strange lithium-ion battery, and beside they had 3 drums with oil. That's maybe not the best idea. Then storage batteries, for example, outside in a 40-foot container or in a lower container away from the building. Then you can also use modern technology such as infrared sensors. Then, because batteries, they will not directly burn, they will become first warm and warmer, and then you have time for reaction. If you have not direct penetration, or it takes normally long. And first, before you have a fire, normally you have a lot of smoke. Then, of course, retention of the extinguisher water, you have to look. You need a fire alarm system, integrate smoke outlets, as I already explained, and you need a concept, and also, of course, most important, training of the people. I come here for the chemical risk ordinance that we have also in Switzerland. That means the chemical risk ordinance is a Swiss legislation that prohibits or restricts the handling of particularly hazardous substances. Like, for example, battery. There's written, for example, I make it short, that the importer producer has to inform and has to take back for free the batteries they sell. That's not only for a smartphone, that it's also for a car. That means the importer really has to look according to this ordinance. This is especially in Switzerland. I guess in other countries this doesn't exist. Really the whole circle from the lifetime of such a battery. It's important. There are also different systems. Also, Karin Jordi is hearing us from iBAT. She is the head of the iBAT system that handles also with these issues. Then you go for second life. The really value of an electric car is the battery. And if the battery is end of life, this is still a value. And not all cells are broken. So when you look here, the battery capacity, and you look here, the lifetime, then we can use the battery in a car, for example, until about 80% of capacity, and this is about 10 years. And after this time, we can use these cells in other battery systems, for example, for storage of solar energy, for example, another 10 years. We have to look which value we can take out of used batteries. And there are also specialists we work together that really check the cells if they are good or not, and then they will produce a new battery system with new BMS. But it's also dangerous because we see a lot of Bastler in Schweizerdeutsch. People, they are not professional, they produce new batteries with different cells, and this is dangerous. And every new batteries is a prototype, and there's a prototype status and must be tested according to UN specs. Yeah. That is not allowed only to make second life and it's good. That is something more than only that. Keep in mind. Then last but not least, to really close this cycle is then the recycling, because in these batteries we have also value in like cobalt, nickel, manganese, lithium, aluminum, iron, graphite, and is also valuable for recycling. I found here a lot of different recycling processes. First of all, normally you make the deactivation of the batteries that like to reduce the energy as good as possible. Then you have, for example, pyrolysis process and metallurgical process and hydrometallurgical. Then you have dismantling and pyrolysis, mechanical, then metallurgical. But a lot of different things they are existing, but with the new EU regulation, you must also recycle the electrolyte, and when you have to do that, you cannot go for pyrolysis or directly for pyrometallurgy. That means first you have really go to dismantle, to take out the electrical energy, that to be safer, to dismantle the battery to cells and make then a crushing, and to take then also electrolyte out and all the metals then, and go then directly to hydrometallurgical systems. In the EU, they are now building about 300,000 tons recycling capacity. That means very soon we have too much capacity for recycle, so go not in this field, go for supporting these plants for that. What means dismantling? This is a big issue. When you have this battery for recycling, you have to dismantle it. You look here at we do all these things. This was a battery, and at the end only this cells is now a module with some cells go then for a crushing process. You see here this module goes then here in a crushing process. This crushing process is on the inert gas or on the water, it depends. Then it goes to a vacuum dryer, the mixing, you have classification, you take then out metals and this black mass where you have graphite in and the anode and cathode materials. So that's all the circle. It's not only recovery of a car. If you do that with batteries, you have a whole cycle you have really to fulfill to make really a good industrial job. We do that, and we have now 3 years experience, and each case was another, and we handle really with dangerous good, and we really have we need also good cooperation, especially with the car industry and also the battery producers and the recyclers, and that works very good. Yes, our service. As I said, we make recovery, transport, quarantine of damaged cars, electro vehicles, and other batteries. And we make also the dismantling until that we work together with Patrick, for example, for the recycling. This is some approved materials we use, the LibaRescue, the LibaTrailer, and this is a blanket for battery recovery. And also this is the fire retardant blanket we use. We make also education, especially in ADR. If somebody from you has questions or not sure in education or website, you find our topics, transport, packaging, storage, lithium-ion batteries in relation to ADR. And if you're interested, and I can show you here, this is a burnt Tesla. And this is Bernd Tesla out of our LibaRescue. So at the end, I will show you the film from my first Tesla. It was a 2013 with 300,000 kilometers. And here it was charging. We charged about 90%. So we have real battery with 85 kilowatt, 90%. Here you see that we took out the battery. Here we opened the battery and put ignition load in. Here, everywhere we had also thermocouples to control what happens. Now we put the car in the LibaRescue. And now we close the LibaRescue for the test. We are allowed to do that in Belgium. Now we have the ignition. And nothing happens at the beginning, and we are afraid that really nothing will go. And now we see we have here smoke that's coming. Here go a little bit faster. So each module was burnt like this, and the LibaRescue looks as the smoke comes out. It's a system without water. Here the front wheels, and now we see at the ignition we have first smoke. See, smoke is coming out. Now ignition from the rest oxygen in the LibaRescue. Now it's extinguished because there's no more oxygen here. Oops, we have some deflagration. First, it was very difficult to understand it because without oxygen you have not such a reaction, but I came in mind that we have a pneumatic suspension, and at 300 degrees the pressure unit failed in the car, and we pressed about with 5 bar, we pressed the air oxygen in the system, and therefore we had this deflagration. And the LibaRescue, the construction is so that we also will be able to handle also such a deflagration. Now we take the car out. We always have opened the window because electric car nothing moves. You see here it's not burnt, it's molten, the plastics. Even you see here the bottom of the car. Everything is okay. So here the plastic is molten, not burnt. The bottom of the battery. What you see at the bottom here without battery is also okay. It's aluminum, it's very good. And the front from the Tesla, also even the 12-volt battery was okay. And inside the leather, the wheel was good. Not the best smell, but it's okay. And here you see all the modules from the battery that's burnt. And we had over 1200 degrees C because the thermocouples were broken. So you see here the battery, the modules, you see each cell was burnt in the thermal runaway, but you see a lot of black things. That means we produced oxygen in this battery, but not enough oxygen to make an oxidation of all the carbon in. So limited oxidation, limited fire. Here now we opened the whole battery, and each module was fully burned like this. And then we cleaned the car a little bit, and you see here the advertisement LibaService on the PVC, it's still existing. Good. Now the car is in my garage at home without target, but it was a good example what happened. It's also the only test I know from such a system that was made with a real car. Last but not least, save the date, we have a second LibaProtect forum in February. Some of you were already there in 2000. And with the items with lithium batteries, new technologies, storage, loading, legal situation, take-back system, electric vehicle recovery, prevention, intervention, and second life and recycling. Save the date, we are together also with iBAT and Christian and Andrea. And so I have finished and give the word back to Christian.
Yeah, many thanks, Victor, for this very interesting presentation. Went a little bit longer than the hour, but I see that basically everybody stayed. It was so interesting. Nobody left. I think we still have time for some questions from the audience. So please raise your hand or write it into the chat if you know.
Yeah, I have a question. Can you hear me?
Yes.
First of all, thank you very much for this interesting presentation. I have a question to one step where you say you take out the battery of the car. Can you comment on how easy this is or how difficult? Are there like common procedures or is this different for every electric vehicle?
It's really no problem. We have a car, we have 4 nuts, and it's down in 5 minutes. We have car, we have 1 day. And if you have a damaged car with deformation and we have tension on, it's very dangerous, and there maybe we have 2 days. It depends on the car. In new cars, the battery is also part of the static frame. There is much more difficult. As it depends from car, we had now almost all cars we already did, and it's from car to car, very special. We have no direct process, and when we ask, nobody gives us information what is to do. But you have to think, you have now, for example, a Tesla. Somebody put the Tesla in the water, and now after 1 week in the water, he asked me, Victor, we need help, we don't know what to do. Then we come, we take the car, we take a total fully flooded battery out of this car, and in the Tesla 3 you have to open inside in the room and out under the car, and then we measure 340 volts on the battery, and everything is wet, and it's the horror. But there are also batteries there. Therefore, we say never make it wet. But if it's dry, it's much easier. But it's difficult. But it's not, as I want to try to say, we need to look for the whole circle, the recovery of the car until that we have modules for recycling, for example. Or an OEM comes and said, look, this battery is okay. We work with OEMs together and decide I will the battery back for my own refurbishment. That's possible.
So basically, you don't have any instructions from car manufacturers how to remove the battery. This does not exist.
We ask always, and it's difficult. For example, it's so when we have a car, then we ask with some OEMs we have very good relation. They are very open, and some manufacturers that they are closed. Maybe they say if something happens, we say what to do, and then we are in charge. But we have the education to handle this. It's not rocket science. It's not so dangerous. But of course, if you have it 800 volts, you make the wrong thing, you become shortly very hot.
Okay.
So you need the education. You must know what to do.
Absolutely, yeah. I think if you say it's not too difficult, and that doesn't mean that everybody should do that at home. As you mentioned it before, this Boston bricolage. Sure. Martin Bolliger, you have another question.
Yes, this is me from TCS Touring Club Switzerland. I actually wanted to ask whether the manufacturers could do better in order to make it easier to separate an unsafe battery from a car. And I think you have just answered this. So the next question would be, is there anything on the regulation side which should be done or pushed in order to make this separation from an unsafe battery more easy or standardized? Do you see a like possibilities to work on that?
So from our part of view, we have no influence in that. Of course, there are companies, they look, that's very easy for handle, also for recovering, and take back also the batteries for recycling. But most of the cars that now in charge, they are not built for demanufacturing. They are built for efficiency.
But would you be interested, for example, on a UNECE level to help bring that topic forward with your vast knowledge and experience?
Of course, we can bring knowledge in, but when you look for the new Tesla battery, how it's built, this battery is really not done for manual demanufacturing. But on the other hand, colleagues of mine, I will go tomorrow there. They have a recycling plant on the construction, and they can put in their whole batteries with 650 kilo without dismantling. So you need to take the battery out of the car and bring it in this big shredder on the inert atmosphere, and then the recycling goes on.
Okay, thank you.
Welcome.
Yes, but I think, Martin, that's a important battery, an important topic, and I think this is something to discuss. There are some new legislations for the EU. There's the new battery regulation, and also a new end-of-life vehicle directive, which is under on the way, let's call it that way. But this has become really a big problem lately, that batteries were only made for higher energy densities, and nobody cares about end of life handling. And this is something also we will address with Circuvat, and everybody is highly welcome to discuss these things with us, and make measures for better disassembly. I think this is, if we want to go to circular economy, and this is I think an important goal of the European Union, and Switzerland should be a part of it. We should discuss those things, and also discuss the manufacturer of the batteries, and try to make them understand better the topic of circularity and what that means for end-of-life handling.
Yes, and the point is, we make laws in order to make manufacturers do what they don't really want to do by themselves, because they have different goals like efficiency and especially cost efficiency. So I think the regulation path should be also in our view.
Absolutely. Is there one more question? Thanks, Martin, for your input, and then thanks, Marcel Held. Is there a third, maybe last question that we can ask to Victor if we have the chance? And if not, as we are almost 15 minutes late, I would like to thank you. And also, again, here it's still written on the desk, the Liba Protect Forum, which we will host at the Switzerland Innovation Park. I think we have a good time there to go more in depth to what we saw today, and point at all the different tasks also to do in order to make electromobility and recycling better. Thanks a lot, Victor, and see you next time, September, for the next webinar.
Okay.